Okay. All right, so today we're going to be talking about volume, all right? And we're going to be concentrating specifically on the volume of certain shapes, as we normally do, but certain shapes can hold only so much. Okay, let's take my water bottle, for instance. Okay, my water bottle has been designed to hold exactly 1.5 liters of water. All right. What does this actually mean for the volume of it? Because before there was water in here, the creators of this Aquele bottle needed to put a particular amount of space inside this bottle. And that is the idea behind volume. Volume is basically how much shape do we have on the inside of a particular how much space do we have on the inside of a particular shape, and how much does it hold? How much liquid does it hold? And that's it, Didimalo. The amount of liquid that it holds is called its capacity. Okay, it's called its capacity. Okay, that's okay. I'm going to explain exactly what it is, gift, so don't even stress about it. All right, so we know that every single shape that we work with will always have a specific amount or a specific base. It will always have a specific base. These days, like these kinds of bottles, we do like really, really fancy maths to figure that out. So don't worry too much. Don't worry yourselves too much about that. There's a computer that does the fancy maths. We're going to be looking at specific shapes that can hold a specific kind of volume that we are familiar with, things that have symmetry. All right, so we're going to look at the volume of any shape as the area of the base of that shape, the area of the base of the shape multiplied by the height. But then again, as always, the height that we're talking about is always the perpendicular height. So we always need to make sure that we have perpendicular height. Let's look at some easy examples of this. All right. We're going to look at these four shapes. Let's look at these two first. I know that this shape over here is a cube, right? Now, if I look at my cube, I know that the base shape of my cube, what is the base shape of my cube, guys? What is the base shape? A triangle, Haibo. A triangle, it's a square, exactly. Good, the base shape is a, now I almost said, you see, gift, what you made me do, now I almost said triangle. It's a square. So I know that the area of my base is going to be a square, right? The area of the base is going to be side times side, or just side squared, all right? I know that it's side squared. So, but because we know that a cube is the same all the way around, I know that my shape is going to be side times side, but my perpendicular height, my height going in this direction, is also going to be the same length as my side. Thumbs up. Are we in agreement that this side over here is also going to be just a side? My perpendicular height is also going to be a side, right? So I know that I'm going to get side times the perpendicular height, which is also side. So the volume of a cube is just going to be side times side times side, which is actually just the same as side cubed, right? So volume of a cube, side cubed. All right, easy enough. Nice and easy. All right, let's move on to our rectangular prism. Rectangular prism. Okay, now if I look at the shape, I know that my base shape is going to be a rectangle. Yes, are we all in agreement? It's a rectangle. Right, it's a rectangle, good. So I know that the area of my base shape is length times breadth, And then I'm just going to take that and multiply that by the perpendicular height. So the volume is going to be length times breadth times height. Yes, like SpongeBob's rectangular prism pants. Exactly. With his cylinder legs. You know, like how he has cylinder legs that come through. Yeah. All right. Okay. Now, I want us to pay particular attention to these two shapes. Okay. And before we pay particular interest to these two shapes, I want us to go back to the cube and to the rectangular prism. I want us to note that the sides that we've picked as our perpendicular heights kind of actually speak to the shape itself. Now, let's think about this base over here. If the base of my cube is a square, if I work myself up, if I work my way up, what kind of shape do I find on the other side of my height? I find a square. Yes, thumbs up. Are we all in agreement? If I go up the height, on the other side of my shape, I find another square. Right. Same with my rectangular prism. If I have my rectangle down here, if I work my way up my height, on the other side, I find another rectangle, exactly like the one at the bottom. Right. So now, if we look at the cylinder over here, if we look at the cylinder, I know that I'm not going to be able to say that's my base. That doesn't make sense, does it? Obviously not the flat side is going to be my shape, my base. That doesn't make sense. Which shape is actually going to be my base? Disproportionate, a little bit. Good, Sanele. It does look a little bit disproportionate. Good. So I know that my base shape is going to be my circle. My circle is going to be my base shape because I know that if I work my way up my height, on the other side, I'm going to find a circle. I'm going to find a circle. So I know that the base of my shape is the circle. So the volume of my cylinder is going to be the area of my base. And I know that the area of a base is pi times radius squared. Multiply that by the perpendicular height. All right. All good? Thumbs up. Are we all good? Right. Let's have a look at our triangular prism because we're going to find the same kind of situation when we get here. Right. I can't now say, that's it, Narisha. I didn't even finish my explanation, but you're already there. Correct. You are there. I can't now say that this rectangle over here is my base and that this is my perpendicular height. That doesn't work because when I go to the other side, if I work my way up my perpendicular height, I don't find a rectangle up here. I don't. So that's not going to be my base. My base will have to be the triangle because if I work my way up my perpendicular height that way, I find another triangle on the other side. Okay, so the volume of my triangular prism will then be half base times the height of the triangle, the perpendicular height of the triangle multiplied by the perpendicular height of my prism. All right, thumbs up. Everybody okay? Are we still doing okay? Yes? These are quite easy. They're nice and easy. We should be able to get through them okay. All right, let's go to some prisms and some cones. All right, so these formulas you're going to have to learn. You can take a quick screenshot. Okay, remember we're looking at pyramids. This is a triangular-based pyramid, triangle-based pyramid. Okay, and as always, remember when they say the area of, okay, sorry, Tidi Malo. Okay, you've got 5 seconds. 4, 3, 2, 1. Not quite, Theo. This one is a little bit more complicated, and I'll show you why. Okay, I'll show you why. Don't stress. Don't stress. I've always got you. Pyramid schemes. Okay, all right. So let's remember a couple of things. Okay, let's remember a couple of things. When we are talking about the area of the base, we always know that this is the base shape. Okay, it's always the base shape. So I know that my base shape is going to be a triangle. My base shape is going to be this triangle, right? But the other thing I know is that my perpendicular height needs to come from where? It needs to come from the apex of my pyramid. So it needs to come from there straight down into the middle of my triangle. And then from there, we can draw a line from there to the apex of my triangle. And that will be the perpendicular height that we use. That will be the perpendicular height. Okay, so it's a little daunting, but because we don't really teach the formula of how to find the middle of a triangle, we'll always give you the perpendicular height of that one. The square-based pyramid, not so much. Square-based pyramid, we should be able to find the middle of the circle. Okay, sorry, not the pyramid, the pyramid. Okay, again, I know that it's a square-based pyramid, so I know that I can calculate the area of the base, which is just a square, okay? And then I know that for my perpendicular height, I need to take space from there all the way down like that. And then from there, I can draw a line from there, going there, and that will be my height. But this one, we've calculated for this one. When we were doing surface area, we calculated for the perpendicular height from a square-based pyramid. Okay. Okay, yes, that's true. But yes, Gift, they normally give us the perpendicular height, especially for the right triangle. All right, unless they give you a way to calculate how to meet that middle point, not really, you won't be able to know. All right, but they will definitely give us the answer. All right, let's look at this next two over here. Again, take a screenshot if you need to. Let's look at this one. All right. Okay, now this one is a cone, and it's quite nice and easy. Look at the formula that we've been given over here. It's quite nice and easy. And the reason it's so nice and easy is because we know that if I were to draw a line from the apex straight down, what do we call that point? What do we call that point on my base of my cone? It's called the what? Not the radius. You are there. You are almost there. It's just the what of my circle. Not the radiation. What do we call it? The what of the circle? The center. That's it. It's the center. Thank you, Sanele. It's the center. And we know that if we want to create a perpendicular height, we just need the radius. So you are almost there, Sanele. You are almost there. It's the center. And the center then allows us to find the radius. Is everyone okay with that? Are we good? Yes? Okay, lovely. And for a sphere, you never have to worry about a sphere. They will always give you the center of the sphere, and from the center to anywhere, we will always be given the radius. So, okay, let's take a look at all these formulae. Let's put them together. I may be a little mean later on in the lesson, but let's start with some nice, easy stuff. All right, can I give you guys 4 minutes to calculate for the volume of these two shapes? Yes, we'll call it shape A and shape B. This is easy. This is nice and easy. we're just going to use the area of the base times the perpendicular height. All right, 4 minutes. Let's go, guys. Gift, which part do you need to take a screenshot of? Okay, these two are easy because you just need to find the base and multiply by the perpendicular height. So it won't matter. We'll come back to the other ones. Okay, I'll go back in a little bit. All right, peeps, are we ready? Shall we have a look at the answers? Yes. Okay, awesome. Okay, so in A, I know that I can use that as my base, but really because it's a rectangular prism, I could use any of them as my base. It wouldn't matter. Let me show you why it wouldn't matter. If I used this part as my base, I know that if I used my height going in that direction, I'm going to come out with the same shape on the other side. So it wouldn't make much of a difference if that was my base. Even if this front part over here was my base, I know that it's okay because when I come out on the other side, I'm going to end up with the same kind of shape over there. So for a rectangular prism, it doesn't matter which one of them is the area of the base, as long as we have the correct answer at the end. So I know that volume is going to equal the length times the breadth of my rectangle times the height. So that's just 8 times 7 times 2. And the answer I should get is 112, 224. How are we getting 224, peeps? 8 times 7 is 56, yes? Yeah, 800 is 56 times 2 is 112 meters cubed. All right, and that's all. Yes, I think you did. It's okay, it happens. It happens. All right, so in this one over here, in B, I know that my base shape will have to be my triangle, because if I come out on the other side, I need the same shape over there. So I can't use the bottom base. I need to use that part. So because that and that are the same, I know that my base, the area of my base should be the rectangle. So my volume is equal to half base times height of the triangle multiplied by the perpendicular height. All right, and that will equal half of 4 times 3 multiplied by 7. Half of 12 is 6 times 7 should give us 42 meters or centimeters cubed. All right, easy things. We can do this in our sleep. Let's try a little bit more. Okay, let's look at these two. The first one is nice and easy. It's just a cylinder. It's just a cylinder, but let's look at this one over here. Okay, this is C, this is D. If we look at D specifically, we can tell that the base shape, what do we call that base shape that we're looking at there? It's not a rectangle. 2 seconds. There we go, Sanele, 2 seconds. That's it. That's it. Okay, Sanele, can I move? I'm moving. Okay. All right. It's a trapezium. And so let's look at what we can do here. If we use the bottom rectangle as a base shape, if I come up, I do end up with a rectangle, but it's the wrong size. So I can't use the bottom shape as my base. I need to use the trapezium because there's the trapezium there. And if I work my way down the height, I end up with another trapezium on the end of the other one. All right, so I end up with a trapezium on the end. Now, I'm going to assume that everybody has forgotten the volume, the area, the formula for the area of a trapezium. Yes? I'm going to remind you. The area of a trapezium is A plus B divided by 2 multiplied by the height. And just to remind you, that side is A, that side is B, and that height that we're talking about is always the perpendicular height, which they've given you in this case. So we should be able to calculate for this one pretty okay. All right, again, 4 minutes for C and D. One day when you and your partner are installing shelves, cool looking shelves into your new house, you're going to want to know how to install trapezium shaped shelves into your house, and you'll need the volume, Narisha. Look at ma'am making up a scenario. Hi, Wo. What if your partner's not so great at math and you're lovely at math? You're so good at math. Your partner's going to need you. Oh, wow. Send them 2 lessons. Sure, of course we can. All right, peeps, are we ready? Can I look at the answers? Should I give you a few more seconds? Sanela's ready. Oh. All right, let's have a look. Okay, so I know for my cylinder, the volume is going to equal to the area of my base, and the area of my base is pi times radius squared multiplied by the height. For this particular one, I need the radius. And at the moment, they've given me the diameter, and I know that The diameter or the radius is going to be half my diameter, therefore radius must equal 20 centimeters. Okay, so my volume is equal to pi times 20 squared multiplied by 32. And I'm going to leave my answer with pi on it. So with pi in it, so if you've kind of rounded up, it's probably because you've clicked SD. I'm not going to do that. I'm going to leave my answer as 6030 pi. You are allowed to do that if you'd like. It's not necessary for you to click pi, especially at your age, unless the question specifically says to 2 decimal places or to 1 decimal place, then we absolutely have to. All right. Okay. Let's look at the volume of our trapezoidal prism. Okay, so I know the volume is going to be the area of my trapezoid or my trapezium. So I'm going to have A plus B over 2 times the height of my trapezoid multiplied by the height of the actual prism. Okay, and that will give me 14 plus 20 divided by 2 multiplied by the perpendicular height, which is 12, times that by 15, and that should give me 17 times 12, 17 times 12 times 15. 17 times 12 times 15 times 15 is equal to 3060. I think I may have got the first one wrong, guys. Don't quote me on that. Pi times 20 squared times 32 equals 12,800 pi. Sorry, guys. Clearly, I was not paying attention. 12,800 pi. Sorry. Okay. Yes, Abu, you did the right things. It was ma'am who got her answer wrong. It was me. Sorry. All right, peeps. Are we okay here? Thumbs up. Is everybody okay with the questions we've just done? Nothing too hectic. Nothing too hectic at all. Let's look at some pyramids. All right. I'm going to remind you again that for a rectangular prism, oh, yes, the unit. Sorry, Sanele. Sorry. Centimeters cubed. Thank you. Centimeters cubed. Thank you. Yes. You caught me. I was testing you and you passed. Well done, V and Sanele. Good job. I was just checking, guys. I was just checking. All right. Okay, let's look at the next 2 questions. I'm going to remind you guys that for these 2 pyramids, the volume is going to be 1/3 of the area of the base multiplied by the perpendicular height. And look at that. Lo and behold, they have given us the perpendicular height in both scenarios. So this shouldn't be difficult at all. All we really need to do is calculate for the area of our base. Thumbs up. Is that easy? Can we do that? Is everybody okay with doing that? Yes. Amazing. You've got 3 minutes because these 2 are not very difficult questions. Okay, let's go for it. Did you malo 2 seconds? Okay, I'm moving back up. Okay, if I didn't give you the right part to look for, I'm happy to scroll up again once we're done here. Okay. Sorry, Sanele. It's actually very cold where I am. I don't know where in the world you are. All right, guys, are we ready? Shall we look at the answers? Okay, cool stuff. All right, so let's look at A, the volume for A. I know that the base of my shape, the base of my pyramid is a square. So I'm just going to write the volume is equal to 1/3 of the area of my square. It's just going to be 6 squared multiplied by the perpendicular height, which is 4. Quite simple, right? And that's just going to give me 6 squared is 36. 1/3 of that is 12 times 4 is 48 meters cubed. Simple. Okay, the volume of this one, I know that my base shape is a triangle, so it's just going to be 1/3, sorry, 1/3 of half times the base, which is, I could choose 6 times 8, okay, multiplied by the perpendicular height, which is fine, 5. Okay, so this is just going to be a half of 6 is 3. 3 times 8 is 24. 1/3 of 24 is 8. 8 times 5 is 40 meters cubed. How did we do? Very simple. Very nice and easy. Yes. Simple things. Awesome. All right. Let's look at some complicated-ish kind of things. All right. Okay, I'm going to put these composite shapes up on the screen, number 1 and number 2. Can I ask you guys very quickly, thumbs up. Do you think you can do these? Do you want to do these on your own? Do you think you can? Thumbs down if you'd like me to walk you through them. What are we thinking? Okay, V says no, Theo says no. Okay, how about we do this? How about I help you conceptualize and then you guys calculate? Does that sound okay? Yes. I'm going to help you guys break it apart and then you guys are going to do the calculation. That sounds like a deal. All right, lovely. Okay, so let's look at this first shape. We can tell that this first shape is made of 2 other shapes. Okay, I know that this is going to be made of the rectangular prism at the bottom, right? At the bottom, and plus the top shape, which is a triangular prism, like that. Okay, now the only thing that we're missing really is the dimensions of each of these, right? Let me just extend that backwards a little bit. Okay. There we go. All right. So what I know is that for my rectangular prism, this side over here is 4,2 meters. Over here we get 6 meters. And for my perpendicular, we get 2 meters. Thumbs up. Everyone okay with that? Are we all good? Yes. Simple things. All right. Let's translate some things. I know that if this part over here is 6 meters, that part of my triangular prism is also 6 meters, which means this side over here, this very badly drawn side, is also 6 meters, right? If this part of my rectangular prism is 4,2 meters, that part over there is also 4,2 meters because it's a rectangle, which means the base of my triangle is 4,2 meters, right? And luckily for us, if we look at the question over here, they have given us the perpendicular height of our triangle. So we know that the perpendicular height of our triangle, oh my goodness, I don't even know what that is. Okay, the perpendicular height of my triangle is 1,4 meters. All right. And we are then able to calculate for the volume of each of them. Is this okay? Thumbs up. Can I leave you guys to it from this point on? Yes? Amazing. You've got 3 minutes. 3 minutes. Take it away. No, Gift, it's not like that. It's not like that. It's not you, it's me, you know? Yes, Abu, you can do 2 as well once you're done. One more minute, guys. Actually, less than a minute, but yeah. All right, peeps, let's look at the answer. Okay, so I know the volume is going to be 2 shapes put together. So I know that my volume is going to equal length times breadth times height plus the area of this base shape. And we know that the base shape is going to be the triangle because I need the same shape to come out at the other side. So that's going to be half base times height multiplied by the perpendicular height or the height of my prism. All right. And that is equal to, oh, look at that, some challenge down there. We'll get to that in just a second. All right. So the volume will equal to 6 times 4,2 times 2 plus half of my base, which is 4,2 times my perpendicular height, which is 1,4, all that multiplied by the perpendicular height of my prism, which is 6. And all of that should give us 68,04 meters cubed. Did we do okay? Yes? Did we get it? Yeah, I told you guys. I told you. Okay, I was leaving you for your own good. See, Gift, sometimes you need to be left alone. 67,64, let's see. 6 times 4,2 times 2 plus, I'm just going to go 0,5 times 4,2 times 1,4 times 6 equals 68,04. We're here for you in spirit. I'm kidding, Gift. I'm kidding. Oh, okay. All right. So in that case, Sanele, then what you need to do is not round off. Okay. Don't round off until the very last answer. Okay. Because it looks like you're about point something off. Okay. So just don't round off until you get to the very end. Okay. All right, shall we look at number 2? Let's break number 2 up into its parts as well. Okay, let's break number 2 up. If we look at number 2 over here, again, we're going to have the same kind of situation, right? I'm going to get the bottom shape, which is going to be a rectangular prism again. Right? It's going to be a rectangular prism. Sorry, guys. It's just, I don't know why my thing is acting weird. There we go. Okay, it's working. All right, so this is 7 centimeters, this is 9 centimeters, and that is 5 centimeters. And we're going to plus that with, now if we look at this top part over here, are we all in agreement? This is half a cylinder. Yes, it's half a cylinder. Yeah, so we're going to calculate for the area of a cylinder or the volume of a cylinder, and we're just going to take that and we're going to divide it by 2. We're going to half that. Okay, so we're going to have plus half the cylinder that we get here. Please don't judge my drawing. It's not fair, guys. I'm just a maths teacher. All right, so we can then translate some things. Okay, we can then translate some things. I know that if this part over here is 7 centimeters, this part over here is also 7 centimeters, and that's that part of my half circle. But I know that this part from there to there of my half circle is actually the diameter of my circle. And in order for me to calculate for the area of a circle, I would need the radius. So I know that the radius will equal 3,5 centimeters. Okay. All right. And then I know that if this part over here is 9 centimeters, then that part over there is 9 centimeters, which means the height over here will be 9 centimeters. And whatever answer we get for this volume, we are just going to multiply it by half. Thumbs up. Can we do this one all our own? Are we good here? I'm going to let go. I'm going to let you guys do what you got to do. You've got 3 minutes. Take it away, guys. And then we can look at one challenge question before we go. All right, peeps, are we ready? Should we have a look? No, I'm not hearing anything. I'll give it 1 more minute. Okay, a few more seconds. Short stuff is done. Theo's done. All right, that's good enough. Okay. 2 people are done. That's the whole class most. 2 people is the whole class. It's fine. All right, let's look at the calculation. Okay. Okay, I'll send you the link, Abu. The link is in our Google Classroom, by the way. The link to our playlists. Okay, so the volume over here is going to be length times breadth times height for our rectangular prism, as always, plus we're going to take half of the area of my base, which is my circle, half of the circle times the perpendicular height. Okay, all right, so that's going to be 9 times 7 times 5 plus half of pi times 3,5 squared multiplied by 9. Okay. All right. And Abu's already got an answer. Let's see if his answer is the same as ours. 9 times 7 times 5 plus half times pi times 3,5 squared times 9. 488,18 488,18 centimeters cubed. All right. Are we all good? Everybody okay? Yes. Nice things. I told you guys I was going to be nice. I wasn't going to be mean today. Okay, let me be mean now. Let's be a little bit mean. Can we be a little bit mean? No, no. Sorry, guys. Let's have a look. Let's have a look at a challenge question. Okay. It's not even that challenging. All right. So it says here, we are given the volume. V is equal to 808 and a third pi centimeters cubed with a radius of 31 centimeters. Find the height and the surface area. Okay, we're going to run out of time. So let's maybe not do the surface area today. Let's look for the height at least. Okay. All right. So what we do know is that we've got a cone, right? Let's remind ourselves what the formula for the volume of a cone is, right? So we know that the volume of a cone is equal to a third, or am I lying? Wait, guys, I feel like I'm lying. Hold on, let's go back. No, I'm not lying. There it is. A third pi times radius squared times the height. Guys, let's focus on the lesson. Okay. All right. So we're going to get a third times pi radius squared multiplied by the height. Okay. Now, let's look at the things that they've actually given us. Let's take stock of what they've given us. At the moment, they've given us the volume. They've also given us the radius. And the only thing that's really missing is the height. Yes? Thumbs up. Are we all okay? Yes? Do we understand what ma'am is saying here? All right. So all we're going to do is we're going to substitute in what we've been given, and then we're going to calculate for the height. So I know that I can replace the whole of the volume with 8,008 pi, or a third pi. So I can go 8,008 times 1/3 pi, and that is equal to 1/3 pi multiplied by, I'm told that my radius is 31, so I'm going to go 31 squared times the height. So do you guys see that actually all we're solving for here is for the height, right? We're just solving for the height. So now all we need to do is make the height the subject of the formula. Now, what I'm going to do first is I'm going to first figure out what this 31 squared is. I want to know what 31 squared is. All right, so 31 squared equals 961. So I'm going to do that. I'm going to say 8,008 a third pi is equal to, now I know that 31 squared is 961, and then I also have a third pi, multiply all of that by h. Right, I now want to make h the subject of the formula, So what will I do? Easy things, right? Not that difficult as all. We'll just divide by everything that's not h. I will just divide this side by 961 1/3 pi. And what I do on the right-hand side, I will do on the left-hand side as well. Divide by 961 1/3 pi. Right? Those two will cancel each other out, and therefore h will equal, if I punch that into a calculator, what am I going to get? Okay, now I don't even have to punch the whole thing into the calculator, because I know that 1/3 and the 1/3 will get rid of each other. I know that pi and pi will get rid of each other. So the only thing I'm really putting into the calculator is 8008 divided by 961. Who can give me an answer? That's it. That's it. The answer we will get for the height is 8,33 centimeters. That wasn't that difficult. That was not that hard. Not at all. It's pretty okay. Let's look at this next one over here. Okay, same situation. We're just going to skip out the surface area part. I'm going to remind you guys that the volume of a sphere is 4/3 pi times radius cubed. Okay. They've given us the volume. They want us to find the radius. Okay. All we have to do is substitute in. All right, I think we're going to stop here for today.